All right, guys, we are going to do some example problems from your gravitational potential energy homework. What I want you guys to remember is that gravitational potential energy is the exact same equation as potential energy. The only exception is you will be using the acceleration of gravity, which is 9.8 meters per second squared, rather than any acceleration given. And remember that the potential energy equation is potential energy equals mass times gravity times height. So, a baby carriage is sitting at the top of the hill that is 21 meters high. The carriage has a mass of 1.5 kilograms. Calculate the potential energy of the carriage. So let's look at what variables we have. We have a mass of 1.5 kilograms. We know that gravity acceleration is 9.8 meters per second squared, and we know that the height is 21 meters. So all we have to do is plug it into this equation. So potential energy is equal to mass times gravity times height. So potential energy is equal to 1.5 kilograms times 9.8 meters per second squared times 21 meters. So let's plug that into our calculator. 1.5 times 9.8 times 21. Let's type that in again. 1.5 times 9.8 times 21. And we get 308.7. So the potential energy is 308.7. What is the measurement for energy? Same thing as work, which is in joules. So our final answer is 308.7 joules. All right, for this next one, we have a cinder block sitting on a platform which is 20 meters high. So the height equals 20 meters. It has a mass of 8.0 kilograms. So the mass is 8.0 kilograms. Calculate the potential energy of the block. The only thing that we were not specifically given is gravity, but we know that the acceleration of gravity is 9.8 meters per second squared. So all you need to do is plug this into that potential energy equation. So potential energy equals the mass, which is 8.0 kilograms, times gravity, which is 9.8 meters per second squared, times the height, which is 20 meters. So all we're going to do is we're going to type that into our calculator. 8 times 9.8 times 20, and we get a potential energy of 1,568, and our units are going to be joules. All right. I'm going to let you guys solve for this one, but the key is already posted. Let's go ahead and do number 4 together. A driver has 3,400 joules of gravitational potential energy after climbing up onto a driving platform that is 6.0 meters above the water. What is the driver's mass in kilograms? So rather than solving for potential energy this time, we are going to be solving for mass. So let's go ahead and identify our variables first. We have the potential energy, which is 3,400 joules. We do not know the mass, that's our unknown. We have gravity, which is 9.8 meters per second squared, and we have a height of 6.0 meters. If we have the equation, potential energy equals mass times gravity times height, we're just going to plug this in. We have the potential energy, which is 3,400 joules, is equal to some unknown mass times gravity, which is 9.8 meters per second squared, times the height, which is 6 meters. So let's go ahead and just combine our like terms. This side's going to stay the same. We're going to have 3,400 joules. Mass is connected, but we can go ahead and multiply 9.8 times 6. 9.8 times 6 gives us 58.8. Those meters are going to stay. Seconds are going to be lost, so 58.8 times meters, or the mass rather, I'm sorry. Divide that by this number, 58.8. That will cancel out. Divide this side by 58.8. What you will be left with is m on this side, and 3,400 divided by 58.8 gives us 57.82. Now, you don't have a unit. What is the unit for mass? Always is going to be kilograms. So your final answer is going to be 57.82 kilograms. And if you have trouble rearranging those equations, make sure you come in and see me, okay? Let's go ahead and flip it on the back. I'm going to do 2 of these problems, okay? These look a little bit intimidating at first, but once you go through them, you're going to realize they're just the exact same as what we did on the front, okay? So we have the Millennium Force, and its mass is 910 kilograms. The lift height of the main hill is 94.5 meters, the track length, the second hill height, and the third hill height. So calculate the potential energy at the top of the main hill. So we know that potential energy is equal to mass times gravity times height. The mass, 910 kilograms. Gravity is not going to change. That's 9.8 meters per second squared. The only thing that's going to be different in these problems is height. And because I asked about the main hill, you're going to use the height 94.5 meters. So potential energy is equal to the mass times gravity times height. So you would do 910 times 9.8 times 94.5. Type that into your calculator. 910 times 9.8 times 94.5. And you will get a huge potential energy of 842,751 joules. All right, the next one is asking you to calculate the potential energy at the top of the second hill. So same exact thing. The only thing that we're changing is the height of the second hill. So we know that potential energy is equal to the mass times gravity times height. Well, the mass is the same. It's going to be 910 kilograms. Gravity is the same, 9.8 meters per second squared. The only thing that changed is the height of the second hill, which is 51.5 meters. So all we need to do is plug this in, 910 times 9.8 times 51.5, and you will get a grand total and a potential energy of 459,277 joules. You're going to do the exact same thing for the third hill, and your grand total should come to a potential energy of 494,949 joules. And the last problem says, does the potential energies come out to be the same? Why or why not? No, they're all different. Why are they different? They're all different because we use a different height depending on what hill we have. So if we're looking at the equation, potential energy equals mass times gravity times height, even though it has the same mass and gravity, when the height changes, the potential energy increases. This is a lot like that roller coaster worksheet we worked on. So no, because of the heights. All right. These problems I'm going to let you go ahead and do on your own. This key is already posted on our Canvas module under Energy and Work. Go ahead and check it out, and if you need extra help, please come in.